In this video, I'm going to introduce you to variables. Now, I don't expect you to know anything about variables. As a matter of fact, you probably should just be starting programming with this. If you have any experience with variables, this is probably a little bit beneath you. So I'm just going to quickly go through variable declaration and assignment, and I'm not really going to go through a grocery list of the different types of variables and what they're used for and the scope of all of them. That'll be the topic of a different video. Today I'm just going to go over just the variable basics. I'm going to go over strings, and I'm going to go over integral variables. And we're going to talk a little bit about the difference between real numbers and integers. Now, what you see here is you see a very simple Java program. Now, in this simple Java program, we're just doing the typical hello world, and we have our main method. Now, just as a review, your main method is the entry point into your Java program. And it takes in it a list of strings or an array of strings, and we won't talk about that right now. We're just going to talk specifically about variable declaration. Now, what a variable is a data structure in a language that allows you to store a value. Now, just about any language that you're going to work with or you have worked with uses variables. Now, the types of variables and what can be held in them differs from language to language, but the concept really remains the same. It allows us to keep a value for a specified amount of time. Now, keeping the value has a word for it or a term. It's called persistence. So we talk about persistence a lot when we're talking about structured programming. Now, persistence in English just means keeping a value for a specific amount of time. So, for example, if I brought you all in front and there's 5 people in class, and I'd say, all right, I want each of you to remember a number. I'm asking you to persist a number. Now, let's just say, for example, I have one of you volunteer. So a show of hands, one of you volunteer, please. Okay, you in the front row. So I will ask you to remember a value. I'll say, I want you to take my name, I'll take my age, and I am 39 years old. Okay, it can happen, right? So I ask you to remember what my age is. And then what I do is I wait 10 seconds and I kind of hum the theme song for Jeopardy. Do, 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 do. And I ask you, I'm like, what is my age? And then you would say, you are 39 years old. So you are persisting that value. So the term persistence is used a lot, and it's used for other things as well. But that's a good term that you could start with, or a good meaning, one meaning of the term persist. Now, another thing that you have to think about variables is there are different times where you can forget something and remember that. Now, that's called scope. Now, I'm not going to talk about scope today in more detail, but let me at least give you the concept of what scope means. If I brought you up here again, and the same person that volunteered to remember my age, please volunteer again. Okay, so I ask you to remember my name, and my name is Bob. So then I hum, again, the theme from Jeopardy, and then 10 seconds later, I say, what is my name? And then you say, Bob. Good. Okay, so you persisted that value, but you also remembered it, okay, for a specified amount of time. Now, let's just say I give you a different name. I give you the name Cadence, and I say, I want you to remember the name Cadence. And then I count to 20, and I say, what is the name I want you to remember? And you say the name to remember name was Cadence. And I'm like, good, good. Now let me count again. So I count up to 50. And I say, all right, I want you to tell me the name that you are supposed to remember. And then you say, I don't know the name I'm supposed to remember. So basically you forgot it. That is called scope. Scope is how long you're expected to know about a specific value. So variables have two things. They have persistence and they have scope. Persistence is the value that is kept in the variable, and scope is how long they're expected to keep it. Now, scope is, like I mentioned, a little bit more of a complicated topic, so I'm going to reserve that for a different time. But at least we got the definition out of the way. What I want you to take away with this is, as far as scope goes, is the scope of variables is almost never forever. There's always some sort of scope, or basically when a variable is allowed to forget or not persist what value is within it. Okay, so that's a lot of definitions for some dude like me that has not written one stitch of code yet. So let's get to it. So we got variables out of the way. Definition of a variable, U in the front row. It is a data structure used to remember or persist a specific value. Now, those that know me, I'm not that big on definitions. You could probably come up with your own. I'm big on the main idea. And I would say, okay, you in the second row, volunteer to answer this question. What are two things associated with the variables? And you would say, well, they're persistence and scope. Persistence is the value that they're asked to keep, and scope is how long they're asked to keep it. Okay, good. So let's talk about the value that they're expected to persist. First of all, let me talk about strings. And what I'm going to do here is really just over the next few minutes or so, I'm going to talk about two different types of variables. I'm going to talk about strings, and I'm going to talk about whole numbers. So how about this? Let's start with a variable declaration. So in my main method, I'm going to declare a string, and I'm going to call this name. Okay, string name. And I'm not going to get into the naming conventions of variables. I will leave that for later. In Java, when we declare a variable, what we do is we start with the type of the variable, or the data type, right? Now, here we have a string. Now, strings are really available in all languages. And let me take one step back about variables. Variables, as I mentioned, vary from language to language, depending on which languaging you're using. Now, but basically, and I'm lying a little bit about this. I'm using the 80-20 rule or the 90-10 rule. Basically, variables distill down into three different types. You have numbers, you have strings, and you have dates and times. Dates and times are one thing, date times. So three things, with some exceptions to those. Strings are anything that you don't perform math with. For example, my name, Bob, would be a string. You don't perform math with Bob. For example, my first name is Bob, and my last name is Hendry. So I could have basically two strings, right? String for my first name would be Bob, and I could have a string for my last name. And I'll do that. How about this? String first name, and we'll do string last name. So basically here, I could have the first name, and I'll put equals to Bob. Now, when we work with strings in Java, we use double quotes. Some languages are different, but in Java, we use double quotes. And we'll put last name equals Hendry. There we go. And we'll do system out print line, first name, and the second one will be the last name. And I'm not going to bore you too much in writing lines of code because I want to illustrate the main idea here. And the goal isn't just to kind of give you a longer video and watch me type, because no one likes that. Who likes watching people type? I don't like watching people type either. All right, so here I have what? For an imaginary extra credit bonus point, how many variables do I have declared here? You in the back row. Okay, right? There is no back row. I have two. I have two variables. What are the types of the variables? They're both strings. Okay. What is the value of first name, or what is persisted? I'll use programmer ease languages or the terminology here. Bob is persisted in first name, and Henry is persisted in last name. And line 9 and 10, I'm simply just writing these out, right? Print out first name, last name, and to run this program, I click on execute. Everything should run fine. I know it's a little small, right? But there we go. So what you see here is you see variables being declared, variables being assigned, and then doing something with the variables. Now, a couple things with this. Now, this is kind of language specific. So don't write this down in pen. Don't write it down at all. But if you write this down, you'll be writing it down in pencil. In most languages, you have to declare your variable before you use it. Now, most, not all. There's scripting languages that you don't have to declare your variable first. You could just start using it, and the system says, hey, you must be using a variable because I don't know what that is. So we'll just start using your variable. Java does not allow you to do that. You have to specify or declare your variable before you use it. So here I got two variable declarations, and then I have a variable assignment. Are you allowed to assign your variable and define it in the same line? Yes, you are. You can do that. Now, there's some ramifications and consequences of that, but for the most part, yeah, the answer to that is true. True or false question. Can you declare your variable and assign it in the same line? Yes, Bob, true. You can do that. So some languages don't allow that. Some languages you have to declare and assign on different lines. So just know that if you go from language to language, and hopefully most of you will, that there's going to be different rules with working with variables. You just have to learn what they are. They work differently. So here we have two strings, Bob and Henry. Now remember what I said. Strings are things you generally don't perform math with. Now let me explain that a little bit. Because some of you are thinking, it's like, wait a second. Strings look a lot like alphanumeric characters. Okay, an alphanumeric character in the English language, right? In the English language, we have what? We have 26 alphanumeric characters, and we have what are called special characters, right? You know, the plus sign, the dollar sign. We have all of those as well. But let's just stick with alphanumeric characters, right? In the English language, we have 26 of them. Now, they can be upper or lowercase, right? I could have here for first name, I got an uppercase B, a lowercase O, and a lowercase b. So you might think to yourself, so strings are only for alphanumeric. But Bob said that strings are things you don't perform math with. And let me show you why. Because you can do something like this. We can say string, and we could say age. And I had a syntax error here. Let me put in, for the last name, let me put a semicolon there. I need to have a semicolon there. Okay, and I'll put in the age of Bob is 29 years old. 29. If you believe that, you're pretty far out there. As a matter of fact, if you believe that, you're so far out, the buses don't go there. Haha, my wife loves that one. All right, anyway, this is valid. There's nothing wrong with this because even though 29 aren't really, they're not letters, right? It's a 2 and it's a 9. I'm not doing math with it. It's a string, right? So I could do, 29 or whatever, but I'm not performing math with this. So what I want you to do is while you're learning about variables, I call it soft learning. Don't necessarily look at this stuff and write it all down as it was the sacred scrolls of, Bob says alphanumeric versus doing math, doing whatever. Just soak it in. I call it soft learning because a lot of this just kind of soaks in as you go. You don't got to crack a book. Just as you're going through it, you kind of learn it softly. So don't worry about necessarily definitions at this point. So I can say something like this. I can say system output line. And I can put in age. So it'll say Bob Hendry 29. So let me just do a quick execute. And I should see Bob Hendry 29 in my results pane on the right hand side. Now these are all strings, right? Strings are fairly easy to work with. Is it more complicated than this? Yes, because they're string functions. We can concatenate things together. If you wanted to concatenate the first name, the last name, we can search within strings. We could do all sorts of that good stuff. In time, my friend, just hold on, Grasshopper. We'll get to that stuff in a little bit. Not today, but we're going to get to that stuff in the future. Right now, we're just learning the basics, right? We're learning declare. We're learning all that other good stuff. We're learning persistence. We're learning scope, definitions. Fine. We're just setting you up with some foundations for success. So there's your strings. Okay, true or false question. In Java, a variable needs to be declared before it is assigned. True. It is. It has to be. Or maybe not. Let me rephrase that. A variable has to be declared before it is assigned, and it can be declared and assigned on the same line. I guess that's two questions. So I'm getting myself in trouble. The answer is true. It has to. You can't just not declare variables and use them. Not in Java. Some languages you can. All right. So anyway, that's the basics of strings. Now let's talk about numbers. And then I'm going to cut you some slack and kind of get out of Dodge and let you have this. Remember I said that variables are really defined in three different types. There's three different kinds of variables. Now there's more, how do I say this? That would be just like saying, I got to be careful here. It would be like saying in baseball, there's two leagues. There's the American League and there's the National League. So I can say there's basically two leagues in baseball. Someone would raise their hand and would say, wait a second, there's more than two because there's like all 32 teams. Or if you're into soccer, I could say there's X amount of leagues in the world. And someone would say, well, no, there's like 1,000 teams. It's the same thing with variables. There's three types of variables, but there's many different kinds of them. So let me kind of distill this. Let me talk about a type and a kind. And I'll use baseball, right? And for those of you that don't follow American baseball, my apologies. You should follow American baseball. So in baseball, there's two leagues, okay? So a league is a type. There's two leagues. So there's two types. We get American League Baseball and we have National League Baseball. Now, these types have kinds, as in it's kind of this, kind of that. In the National League, there is, I believe, 16 teams. There might be more. I think it's 16. Just work with me on this. Each team, Cubs, Dodgers, National League, Cubs, Dodgers, Atlanta Braves, would be a kind of team in the type National League. Again, work with me on this. We also have another type called the American League. The American League has kinds in it. The kinds are the teams that play in it. So the Chicago White Sox would be a kind. So the Chicago White Sox would be a kind of team that plays in the type American League. All right, got it? Going to have a quiz on that, right? All right, variables are like that. We have types and we have kinds. There are three types of variables. There are dates. I'm repeating myself. There are numbers and there are strings. Now, of those three types, there's a bunch of kinds, maybe 100, okay? Not today, not today. Right now, we're just going to go through definitions, okay? So what we're going to talk about now is we're going to talk about a type of variable called numbers, right? We all deal with numbers all the time. So for those of you that go back to high school, we're going to go back to high school algebra. I got a funny high school algebra story for you. Not today. I'm a little tired, okay? It's been a long day. Just someone remind me, just so you'll get an extra credit bonus point. Send me an email or a text message and say, Bob, yes, you know what? I did watch your class. Please tell us your funny story about high school algebra, right? And maybe after the statute of limitations, I'll be able to do so. Anyway, so let's talk about numbers. There's two different types of numbers, right? You have integral numbers and you have real numbers. Now, an integral number is a whole number. A whole number would be a number that's represented without a decimal or without a fraction. So for those math majors here, you are used to using or know the difference between integral numbers and real numbers. An integral number would be like, for example, some distinct number like this. I would ask you, how many wheels are on your car? Okay, work with me on this. You would say 4. There's not 4.5. There's not 3.5. There's 4, right? Or I might make it more complicated. I might say, look at the vehicle that you drive most of the time and tell me how many wheels are on it. That number would be integral, which would mean it would be a whole number. If you ride a motorcycle most of the time, right? Cool, good for you. Your number would be 2. If for some reason you drove a quad, you drove an ATV back and forth to school, your number would be 4. If you drove a trike, maybe you do, I don't know. I'm not here to judge. Your answer would be 3. If you drove a car, your answer would be 4. If you drove a tank, it might be 8. If you drove a moon rover, it might be 16. But. Your answer would be a whole number, right? Okay, so those are integral numbers. They're whole numbers. You also have what are called real numbers. Real, R-E-A-L, like real cheese, real numbers. Real numbers can be a whole number, right? Like, for example, if you ask me if I asked you how many wheels are on your car and you say 4. 4 is an integral number and it's a real number. Okay, but real numbers are more flexible than whole numbers or integral numbers. Now remember, whole numbers and integral numbers are the same thing. There's no fraction, no decimal. This is important. It really is. In the world of computer programming, this is very important. But I might ask you something that might not be a whole number. For example, I might ask you, how much money do you make an hour? And let's just say that you're a professor at Triton College and you make $4.23 an hour, right? All right, so let's see if anyone's smiling there. $4.23 an hour is not a whole number. Why? Because it's got a decimal in it. Those are called real numbers. Remember, we have whole numbers and integrals. They're the same thing. That means that there's no fraction. And we have real numbers. Real numbers, there is a fraction. So if and some numbers just don't fall in there. If you wanted to have a conversation over a pint of beer and talk about real numbers versus non-real numbers versus imaginary numbers, which is a whole different thing. And I'm getting into one of my math lectures, which I need to digress from because this is the wrong class. But there's also some numbers that don't really fall into that. If someone asked me, Professor Hendry, how old are you? And I say, I'm 29 years old. All right? Pause for laughter. I probably would express that as an integral, right? But when you're a kid, and if someone says, hi, Bobby, how old are you? And I'd say, I'm 4.5 or 5.5. So there's some numbers that might be integral and they might be real. Keep that in mind that when we talk about real numbers or versus integrals, same thing as a whole number. We're using something to describe a number, kind of like music. When you read a sheet of music, the music just describes what you should be playing. It's not a rule or a roadmap, it's a description. Now, this is important the way you look at it, because when we work with variables, we work with how we describe them. So here, going back to the code, we're describing a few strings, right? Strings are fairly easy, so let's get rid of these. We got strings for now. Let's get out of that. Let's get out of this and go back to here. Let's work with numbers now. So let me work with your first data type called an integer, int, and we're going to put in age. So we'll put in age equals 29, and we'll print out age. So let me just run this real quick. Click on execute, and we should just see 29 print out. And just to digress a little bit, you're looking at this and saying, wait a second, 29 was a string before. It was a string when we used it before because we put quotes around it. But here, we're treating it really as a number. Remember, numbers are things that we want to perform some kind of math with. We want to subtract an age or get a raise percentage, like an hourly rate times whatever. So the first number I'm going to show you is I'm going to show you, put a comment here. I'm going to put in integral or, same thing, whole numbers. Integral or whole numbers. So I got the age. Now, here's the thing with integers. Integers in Java, again, are whole numbers. Let's just say I did this. And I'm like, you know what? I'm going to put the age as 29 and 3/4 years old, if this was important. I'm going to click on execute. And you're going to get, look at this. Oh, pardon me. This is something else here. Let me go back. There we go. And let me click execute again. Okay, I had a problem there that I didn't anticipate. My comment was wrong. I shifted back and forth between languages. So I'm back on track here. This is what I want you to see here. I'm getting an error. I'm getting a runtime error. Why in the world am I getting an error? Because certainly 29.75 is a number, right? But what's the problem with this? It's not an integral number. It's not a whole number. In programming, this is a big deal. In some languages, it's more of a big deal in some languages over the next. But in Java, it is a big deal. You're going to find this is going to be a big deal in C# and also C++. This is going to be a big deal. So integral numbers have to be whole. They can be negative, though. Like, for example, let's just say for some reason I'm negative 29 years old. That's valid as well. But it's got to be a whole number. Money shot. Integers have to be whole numbers. Integers are whole numbers. They have to be whole numbers. So they also have ranges. They can only be so big. And I'm not going to give it to you. I'm not going to tell you how big an integer can be, but there is ranges for how big they are. I'm going to leave it to you to determine this. Take a field trip. Pause the video. Go to Google and just Google Java integer range. And then you'll see a bunch of pages pop up that'll show you the range for integers. Like, for example, you can't have anything like really too big in here. And again, on purpose, I'm not telling it to you. But like if I tried to execute this, you're going to see the integer number is too large. All right. So that's a third thing I want you to know about variables. The first was, right, persistence. The second is scope. The third is range. Home on the range. I'm sorry I had to do that to you. I'm just going to sit in the corner and think about what I just done. Okay, I'm back. All right, so they have ranges to them. And integers are actually fairly small. So what I want you to do is for like a field trip is look up the integral data types and look at the ranges for them. Here, I'm not going to do that. All right. I think that's that's pretty much all I want to do for now. For now, I just wanted to go over definitions. So let me just kind of like circle back and talk about what we did. This was a small beginning lecture on variables. So rather than jumping into the pool and me just starting to write code, I tried to give you a little bit of theory, important theory about what a variable is, what they hold, some definitions of it, and the different types of variables. And more importantly, we went over some very important terminology that we use when we talk about using variables. We went over 2 variables. I could have started with strings and say, okay, do this. That's a string. And okay, now let's do this. These are integers. But I did a little bit more than that. I gave you a background before we kind of jumped in the pool there. Exactly. Some of the foundations. I hate to say the theory, because when you say, well, let's go over the theory of this, people say, I don't want theory, I want practice. Okay, well, let's get rid of the word theory and talk about foundations. Okay, because before we could go over practical, usage of this, we need to have the foundations of how they actually work. And that's what we did here. All right, folks, that's all I had for you today. So thank you for your time, and I bid you all a very well and safe rest of the day. Thank you so much. Hello, everyone. We're going to do a little bit more with variables today. Today, what we're going to do is we're going to keep it simple and light, and today's lecture will be maybe about 20 minutes or 25 minutes or so. And like I said, we're going to keep it light with working with variables. Specifically, we're going to be working with 3 different kinds of variables today, right? We talked about types and we talk about kinds, right? We're going to talk about 3 different kinds of variables. We're going to talk about another integral variable. Remember that integrals are whole numbers. Then we're going to talk about how we can work with decimals. Now, you might not think that's a big deal about in programming languages that working with different numbers is a big deal, but it really is. A lot of times when we're dealing with numbers, at least just in our head on an everyday basis, we don't really realize, what we're thinking about as far as what numbers represent. Like, for example, if we're using like natural numbers, a natural number is something that you see every day, and natural numbers tend to be whole numbers. For example, I'm looking out the window right now, and I could look at various things. I can see in my backyard right now, I have 1 barbecue grill. I have 2 chipmunks that I'm looking at right now that are eating out of 1 bird feeder. The 1 bird feeder is on 1 shepherd's hook. So when we talk about natural numbers and integral numbers, we talk about whole numbers. Now, a whole number is something that is observable. For example, like I mentioned, the things that you look around and you generally see wholes of something. Hopefully you do. Like if I looked outside and if I saw, half of a barbecue grill or 1.5 barbecue grills or 1.5 barbecue grills, something is probably awry. And hopefully I wouldn't see like 2.5 chipmunks, because then I would beg to question what happened to the other half. So integrals are really the most pure numbers that we can deal with. They're whole numbers and they're things that we can deal with every day. Now, without getting into the esoteric, view of things like I have been, that means a lot in computer language and in mathematics in general. Now, I'll spare you the mathematic lesson, even though I've given you maybe a little bit of one, and we're going to talk about how numbers are represented in computer languages. Now, in computer languages, it still represents things that I just mentioned. I mean, you have integral numbers, which are whole numbers, and then you have what are called real numbers. A real number is something that's not a whole number, and it's not an integral. Integrals and whole numbers are the same thing. Like for example, if you did something like if you computed your, let's just say your yearly income, what generally you would do is you would take your hourly wage if you got one, or you would take whatever your salary was and you would multiply it by, how many ever weeks there were in the year. 52, weeks or 12 months or whatever. And you would come up with a number that most likely would be a decimal, right? It would have decimal places on it. You would make $50,000.25, or if you're lucky, a lot more than that, or a little less, but whatever, you probably would have a decimal number. Also, decimal numbers are something that you would do, like for example, if you were computing your age in, I don't know, if you're trying to figure out how old you are specifically, like I'm 29 and a half years old, or 29 point some years. So a lot of numbers that are not really observable, that are not necessarily natural numbers, are still numbers anyway, and those are called real numbers. Now, real numbers in computer languages are represented by different data types than whole numbers are. And then it gets a little bit more esoteric than that. For example, you could get into, for example, what are called imaginary numbers. And an imaginary number is something that necessarily cannot be observed. For example, if you're looking outside right now, you're not seeing negative of something. You're not seeing negative cars or negative anything. You're seeing only positive numbers. So you actually get into a realm where you're dealing with negative numbers. You start talking about imaginary numbering systems, and each of those have their own specific data types or kinds that we work with in computer languages. Thankfully, today we're not going to be talking about imaginary numbers, right? So use your imagination, and we could think about imaginary numbers at a different date. But what I'm trying to get your heads around is, without giving you a math lesson, I'm trying to just explain to you that when you're using computer languages, that the different types of numbers, the different kinds of numbers are important. And they're represented in different ways, and they're all handled different ways. And to make things a little bit more complicated, each language might handle them differently. The good news for you, right? You're thinking about this, like, this does not sound like it's something really easy for me to understand. And it actually isn't. It isn't. It's something that you grow with. Understanding variables and the kinds of variables and I call it numericness of a variable is something that you get over time. But to get up and started quickly, you don't need to know all of this. It's kind of like music. I'm an amateur musician, and I'm trying to learn how to play an instrument, the cello, which is something that I've never knew how to play before. And sometimes I'll listen to people that are really good at it, and it's disheartening to me. And I'm like, oh no, I'm never going to be able to get this. I'm never going to learn this. I'll never understand this. I'll never be this good at it. And then it occurs to me I don't have to be. Not in the beginning. In the beginning, I could work my way up there and just do simple things just to kind of make me feel better. And then know that I don't need to know everything there is to know about that instrument to learn and to be good and get started. And that's how I want you to approach computer languages like Java that we're working with right now. Is I want you to look at it that way, saying this is something I'm going to master over time, but I don't need to know everything today or tomorrow or even over the next week or so. I'm going to learn this as I go. So as a teacher, I always say, as a teacher, always assume people understand half of what they look like they understand. So think about that, right? So as you're learning, you don't need to know all of it. Just kind of get it a little bit as you go. So a lot of this theory, I hate saying theory because you say theory, it's like, either it's useless knowledge and we don't need to do it. So I try to use the term foundations because that's, you do kind of need to know it at least sooner or later to kind of evolve on this. So anyway, the two numbers that we're going to be dealing with today are we're going to deal with a long, which is a natural number, and it is an integral number, which means it is a whole number. And we're going to work with two different kinds of decimal numbers or real numbers. And just to throw something else into the mix, we're going to work with strings a little bit. And I do want to mention to you that this isn't going to be a comprehensive lecture demonstration on variables. I just try to give you the cliff notes. I really do. I try to give you, the foundations of this. So a lot of it, once you know the recipe, you could kind of go out on your own and look up the different ones, because there's so many different kinds of variables in Java. Dozens, right? And if you're working with different languages, there's even more. You're going to find that out if you go into C++ or C#, Visual Basic, Python. Variables are a deep thing, and they get handled differently in each different language. So keep that in mind as you evolve in your learning of computer languages, that what you learn here are really the fundamentals, and you're getting, kind of, the basics and how they work, but you can translate them to somewhere else. I had a student last year that worked at a car dealership, and he was a mechanic, and he mentioned about learning different computer languages. He said a lot of this different languages are like working on different kinds of engines. And I thought that was a good analogy, because he said that if you know the basics of working on, a car engine, an internal combustion gasoline powered engine, when you go from different, types of cars, right? From like a Chevy to a Toyota to a Honda or whatever, you might have to learn a bunch of new stuff, but the foundation is still there. You don't have to relearn everything. I think that's a great analogy when it comes to languages and working with variables. So let's just jump into this. We have a simple Java program here, and we got the system.out line, and let's just warm up here with a couple of simple ones here. Now, integers, which we represent as int, and we're going to put in age, int age, and we'll put equals, and we'll put my age 29. Now, integers are whole numbers, and they're fairly small. I'm not going to give you all the answers. I'm going to give you some field trips here. What you can do is, if you want, is you could, Google's your friend. You're going to hear me say that a lot. Is you could Google the range for these different data types, kinds of variables. So here we got an integer again, which is a variable of an integral data type or a whole number, but it definitely has a range. Some of these variables that you use to hold whole numbers, some of them can be negative, some of them not. Some of them can be larger than other ones. So I'm not going to read you that grocery list, but when we talk about the largeness or how big a variable can be, that's called its range. So the range of an integer is actually fairly small. It used to be 32,767, right? And where did that number come from? Well, if you look at binary, that's if you look at 8 bits, if all 8 bits are flipped to true or on, and you add all those bits up, they add up to 32,767. You don't need to know that, but maybe you should. So ints are fairly small. As a matter of fact, if I try to make an integer too big, we're going to have a problem. So let's give this an execute. So how was everyone today, huh? You all enjoying your day so far? Good. Okay, so actually, you know what? I'm just going to print this out. Print line, and we'll print out age. And again, you're just watching this, or you can follow along too. It's up to you. So let me click on execute, and it shows that Bob is 29 years old. So what we can do is we can do simple math with this as well. But remember, integers are whole numbers that can only hold whole numbers. So let me put an integer, and I'm going to put in, I'll put in my wife's age. Put in wife's age. And my wife is 59 years old. Right? I better not put that in there. Say she is 29 as well. So I can do some simple arithmetic with this. I can say, for example, int result is equal to my age plus my wife's age. Now, don't worry about this arithmetic right now. If you don't know how arithmetic works, remember, I'm assuming you don't know really anything about languages here. So right there, I did some arithmetic. Don't panic. I'm not going to really get too far into this, although a lot of it's going to be kind of intuitive. And we're going to put in a result here. Result. There we go. So I execute this program, and I'm going to get in an error here. What do I got? What's my problem here? Oh, I got syntax error. See, I got wife's age. I need to make this into an S. There we go. Run that again, and I got 58. Now, integral numbers, again, can't be real numbers. So, for example, if I say my wife is 29 and a half years old, this should give me a compile error or runtime error depending on my compiler. So I'm going to get this incompatible types. Lossy conversion. Let's talk about what this means. Lossy just means, actually, you know what? That's actually the subject of another lecture here. But this is what's happening here. What Java, our computer language, is trying to do is it's trying to take something that's not an integer and do math with an integer. Okay, now this is important, okay? Don't need to write this down, but put this in the back of your head. Note to self, when you do math in computer languages, most computer languages, the types have to match. Remember we talked about real numbers versus natural or integral numbers. They don't really add up. Pardon me. They're not compatible when we're doing arithmetic with them in most cases. You can't take one squirrel and add 1.5 squirrels to it, because one squirrel is an integer and 1.5 squirrels is a non-integer. It's a real number. So this won't work. I'm trying to kind of wean you into how to work with decimals here. So you're like, you know what? How about this? We'll make the wife's age 29.0, right? Is 29.0, is it, for an imaginary extra credit bonus point, is 29.0 a real number or is it a natural number? This actually won't work. You would think that 29 is a whole number or a natural number. It's not. Now, I'm throwing these terms around again. Natural numbers, integers, and integral numbers are the same thing. They're all the same thing. All right, so anyway, and then we have the range. Like, for example, I can't have my wife be 29 gajillion years old. I'm going to get a range error here. It's going to say here the number is too large. Look it up. I'm not going to tell you what it is. If you want to know the range of an integer, look it up. Google's your friend. All right, so let's just say that she is that old. How about this? I'm going to take my age, and I won't take my wife's age. I'm going to put in, how about this? Let me get rid of my age here. And rather than my wife's age, we're going to do something that's really, really big. We're going to put in the radius in miles of the universe or of our solar system. Right? Now, I really don't know what this is, the diameter or whatever of our solar system, but it's probably pretty big, right? So just work with me on this. Let's have some fun, right? Let's get rid of the wife's age just for now. And for the results, let's make it, no, let's comment it out. I'm trying to get either a compile or a runtime error here. So anyway, if this is too big of a number, I should get what I expect. And again, I expect this to be, the number is just too big. Now, if you have a whole number that's bigger than an int, there's other data types that you can use. You can use a long. This might be even a little bit too big for that. Make it a little bit smaller. Just a little bit smaller. And there we go. So what I want you to do, and again, I made that insanely long previously. So let me wrap this up as far as integral numbers go. Okay, right now I want you to know of two of them. There's int, stands for integer, and there's long. Okay, those are the two different kinds of, oh, pardon me, I'm talking myself in a circle here. Okay, integers, or int, and long are the two different kinds of natural numbers I want you to know for now. There's other ones as well, but when you're dealing with whole numbers, right, deal with an int or deal with a long. Now, I could have just said that and spared you the other 19 minutes, but what fun would that be? Okay, anyway, let's move on from this. Let's deal with other numbers. Let's deal with real numbers. So I'm going to get rid of this, and I'm going to say, let's deal with real numbers. Now, a real number, again, is something with a decimal in it. Now, there's two different kinds. We have floats and we have decimals. So give me a second. Let me... oh, pardon me. Nope, we have floats. When dealing with decimals, let me retool here. When dealing with decimals, we're going to deal with a double or a float. Double stands for double precision, and float stands for floating point. I'm not going to get into the differences between them. That might be an excellent question for, another assignment. I want you to research the difference between a double and a float. Again, what I try to do is when I put these demos together is I try to stick to something original, like an original demonstration here. I don't really necessarily get into the whole lecture about differences between something when there's dozens, if not hundreds, of other resources out there that already does this. I'm not really big on reinventing the wheel. If there's other resources that'll tell you the difference between a double and a float, research them. They're out there. Find them. All right. Anyway, so for a double, I will do the following. Let's just say I'm doing my salary, right? Or I'm trying to figure out how much money I make a year. So I'm going to put in a double. I'm all fat-fingered here. And I'm going to call this hourly pay. And I'm going to say that I make, how about $12.50 an hour? And here's the thing. I have to put a D in the back of it. D stands for double. And then I will put in, how about this? Double. And we will put in years. Pardon me. I don't know. How many hours are there in a year? We'll forget the year. Let's do how much we make in a week, right? We'll put in hours in week. Now, here's the thing. Now, watch. I know what you're saying, right? You're like, Bob. Hours in a week. Let me ask you this. Is hours in a week a real number, or is it a whole number? It could be either, right? Figure, you're usually, paid 40 hours a week, but not necessarily. If you punch a clock, it could be 40 hours and 10 minutes. It could be 39 hours and 59 minutes, or whatever. So hours in week, we're just going to say we'll play with this. We'll say it's 40. We'll put a D. we'll put in double. And then for this, we'll put in weekly pay. And we'll say your weekly pay is equal to your hour pay times, where is it, Bobby? Times your hours in week. Did I screw up? Yep. I'm just going to do a quick Slick-a-McGee copy paste here. There we go. And we'll do system out print line. And we'll put in weekly pay. All right, so let me run this by clicking on execute. And I got, that's 40G, should be 40, right? D for double. And I'm a little fat-fingered here. Let's try it again. Remember, nothing ever works the first time. I'm just making some on-the-fly changes that get me to compile, and there we go. Okay. So we're dealing with doubles here. So I could say, how about my hourly pay is $12.59, and I worked this week 40.09 hours or whatever. So a double is a real good data type to use for a decimal. Very good. There's also other ones as well. Like I said, we're going to be using doubles and floats. And really for the most part, for our demo here, they're going to act a lot the same. But that's going to be, again, a good topic for, kind of a tangent, maybe video or class about spend some time on doubles versus floats. But that's kind of, believe it or not, and some people that are listening might say this is something we should cover now. I consider that kind of a, it's a beginning thing, but it's not, a day one stuff. Right now, let's just get comfortable working with decimals. It's one of those. And then, yeah, you need to know about floats and doubles and the differences. You do need that, but, on the second day you need that, not on the first day. So let me click on execute. And then you should see on the right-hand side, you get all this right here. Now, take a look at this. When you work with doubles, you don't get, you get quite a number of decimal places. A little bit later, what we'll do is, like I said, right here, we're not going to really worry about this too much. But behind the scenes, believe it or not, when, Java or any language is doing its arithmetic in the background, there's always a little bit of overflow. There's an algorithm it goes through to actually do this math. For the most part, it's kind of invisible to us, but as you progress in your, in your studies of computer science, this is going to become kind of important. Again, not on day one, not on day two, but maybe like day 30, or maybe more than that. We're speaking in metaphors at this point, but at some point, you're going to look at this and say, what is this O for? Because there's actually rounding errors for this, because it's not exactly perfect. Now, another data type that we can use are floats. Now, double is double precision and float is floating point. Don't worry about the differences between them now. For right now, use double when you're using decimals, but you can also use a float. I believe float has, you know what? I got to look this up. You think I would know this off the top of my head. Double actually doesn't have the precision that float does. Or maybe it's vice versa. You know what? You might have me on that. But float generally has more of a precision to it than double does. So if you're doing things that are really, well, how about this? You know what? I'm talking myself into a circle here. All right, so we'll play with both of them. How about this? We have doubles, and we'll say the weekly pay here is using double. Did I tell you how much I love Coding Ground? This is a great tool. I mean, especially for learning just a bunch of different languages. It's so cool. You don't got to configure anything on your local desktop. I mean, as long as you have internet access, you're good to go. You know, no downloading all this crap, no coming to school and going into the lab and, this is so much better. All right, how about we do this? We'll say, rather than hour pay for double, I'm going to change these to floats. And you can just watch this too. Or you can follow along. It's up to you. Float. 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 And we're going to call this one F hourly pay. Whoops. Hold on there, Bobby. F hourly pay. F hours in week. F weekly pay. F just stands for float. I need to name my variable something different. So the F weekly pay, we go back, will equal the F, I keep screwing that up. Stop it. You're fired, Bob. All right, equals the F hourly pay times the hours in the week. There we go. And then the float would be our weekly pay. And also, guess what? When we deal with floats, we have to call it a float. So we'll put an F. Remember, D for double, F for float. They're both data types that we can use for real numbers. One of them has more precision than the other as far as decimals go. So let's execute. So take a look at this. We got double and float. And I like what we did here. Rather than me giving you an answer, which I try not to do, we experimented, right? Remember I told you off the top of my head, I forgot if doubles or floats, which one has the more accurate decimal precision. It's actually double. But double also has some rounding errors in here. Look at this. Float gives us $504.73.31. Double gives us $504. 73.31 blah 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 4. So double gives us a more decimal places, right? But it also can give us some rounding errors. What is this 0 for? You know what? It's an error. It's a rounding error. Well, how can it be a rounding error? The computer gave it to us because computers do have rounding errors, and doubles are susceptible to rounding errors. Does that mean we don't use them? Well, I don't know. That's a good question. If we were just dealing with our like monthly salary, or pardon me, our weekly salary, we could round this and we could display this if we wanted to, and just chop off the point. You know, if we wanted to, we could just chop off the 0.31 all the way to the 4, right? So if we were to display this, and we're not just for the sake of time, but if we were to display this, we could just display, oh, you know what? Let's just display $504.73 and just screw whatever to the rest of that. So basically, in computer ease, we're only going to show the number and then 2 decimal places, right? The first decimal place is the tenths, right? And, you know, using base 10 math. And then the 3 is hundredths, right? Now, I said the obvious. You're like, well, 73 cents. But if you're me, there's 2 decimal places there. One represents the tenths, one represents the hundredths, right? But, and not sure anything else. Screw it. We really don't care. But this can be a problem, right? Because if we're looking at $504.73, that's cool. We're good with that. But what if we were calculating something more precise? Think about what could be more precise than this. You're like, well, we're going down to the pennies, but let's not think about currencies. Let's just say we were doing a scientific program where we are calculating an atomic weight of something. What is it? I don't know. Any chemistry people in here? Or how about this? Or if we're writing a physics program to determine, I don't know, a very small number, right? That error margin might be significant. So doubles give us more decimals, but also can give us some rounding errors. Where float gives us less decimals and it's less susceptible to rounding errors. Now you might look at this and say, well, we're just figuring out, Bob, how many dollars and cents I can expect to make in a frickin' week. And I would agree. And I would say, well, rounding isn't really going to be a big deal here because we're talking about a rounding error of what? 4 trillionths of a penny if we're dealing with currencies. 4 trillionths or whatever decimal place this is. Get it out, figure it out. Email me, say, Bob, that wasn't trillionths, that was 10 trillionths or whatever, billions. It's a very, 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 very small number. So you can look at this and say, well, rounding isn't that big of a deal if we're just dealing with the salary. No, it probably isn't. It probably isn't. But let's just say that we were doing this. How about this? This is a good one. How about this is the interest that we have to pay on a specific bank account? And there's programs that do this. Every night, something runs and says that your $50 in the bank is now worth $50.00003. That might be important because if you did that with 1 million people, that rounding error might become important. And believe it or not, when you do things with that precision, you have this conversation. You really do. You look at this and it's kind of ticky-tack about, well, we're only looking at a few cents here. Well, or trillionths of cents here, but that could be an issue if we're doing something very precise, like calculating interest for 1 million people or calculating an atomic weight or how about this, a solar distance if we're doing astronomy. So when we're dealing, and let me sum this up here. When we're dealing with real numbers, we basically have 2 different kinds that we deal with. We have doubles and we have floats. And there's others as well. You'll find them. There's others out there. Go find them. Let me know. Bob, you forgot to use. I know. But let's just start with a couple and go with the foundation of using real numbers and the precision of real numbers. Okay, let me wrap this up. Right? We have whole numbers. If you're dealing with whole numbers, deal with ints and deal with longs. Int is smaller, long is bigger. If you're dealing with real numbers have decimals. Use a double or use a float. Use a double if the precision of the decimal, it needs to be more precise than a float. A lot of times they're the same here. We're using a double and a float for how much you make in a week. Both of them will do. It's not like you always use one over another, but they're a little bit different. It'd be a little bit different. All right, so that is it. That's what I have for you. So, study your variables. Know that using variables, there's more than meets the eye. And I've been doing this since you were very small. Probably since most of you weren't even here yet. And I learn more about this crap every day. I really do. At this point, it's kind of like alpha geek stuff that I'm learning. It's not really, practical. It's really out there. I mean, it's so far out there the buses don't go. But it's something that you never stop learning about. It's also going to become important when you go to different languages, because different languages support different types of variables. And by no means are you done here with variables. This is just getting you started. Like I always say, how far that's going to get you? How far is that going to get you? Right? Well, this will actually get you, from day 0 to day 1, 2, and 3. And again, days are just metaphors, but I mean, you don't need to know everything, but it's just enough to get you started. You need to learn how variables work when you're working with computer languages, but you don't need to learn everything overnight. Just like when I'm practicing my cello and I listen to my instructor do some incredibly complicated stuff, and I'm like, you know what? I don't need to know all this right now because I'll just go crazy. It's the same thing with languages. You need to keep building on your knowledge and just know that some of this stuff is out there and you're going to get to it, but sometimes you're just not going to get to it today. So thank you so much for your time and for listening to this. I really appreciate it, especially if you made it this far, because if you made it this far, it's farther than I would have made it. So I bid you all a very well rest of the day and be safe. Thank you.